The other ways you can connect shared storage to your vSphere hosts is through direct attached SAS, where you connect your hosts directly to the SAN using an external SAS controller. So it's a SAS controller with external ports, and you have some cables that connect it directly to the SAN. That's great for small implementations using something like a HP MSA 2050 or similar. There's FibreChannel. Now, FibreChannel is not just a SAN that is connected using fiber optic cables. It does use fiber optic cables generally, but FibreChannel is a protocol within itself. It's not Ethernet. It's different to Ethernet. And then there's also FibreChannel over Ethernet, which is where you take the FibreChannel protocol and run that over Ethernet. Now, direct attach SAS, FibreChannel, they both, generally speaking, from a vSphere perspective, when you present those LUNs to the host, you just rescan the HBAs and those LUNs appear. For FibreChannel over Ethernet, you need to do a little bit of configuration on the host. So you go to your host in vCenter, go to your storage adapters, add a software adapter, and you can see we have a software FCOE adapter. This is, of course, assuming you don't have network cards that support FCOE natively. They are an FCOE hardware adapter. This is an FCOE software adapter. To do that with this, you add the FCOE adapter, and you select a physical network adapter to tie it to. So we can use any of the adapters in the host. I'm just going to select VMNIC2. We say OK. And there we go. We have an FCOE adapter attached to the host. And now when we present LUNs to that host on our FibreChannel over Ethernet SAN and do a rescan, we'll see those LUNs appear. So now we're going to configure an NFS data store. vSphere has had NFS support since the early days of vSphere 5. Originally we could only support NFS 3, but now we have NFS 4.1 support as well. NFS is fairly simple to set up and it removes some of the complexity involved in a VMFS file store, in a VMFS data store, because with an NFS data store we're just storing files on a network share. There's no proprietary file system involved. Now that has its advantages and its disadvantages, of course. So to configure a NFS data store, you just go straight to new data store. You don't need to configure any adapters as long as you have networking configuration which allows you to connect to your NFS based NAS. You're all good to go. There is no special config required. We're going to do an NFS 4.1 data store. I'm going to call it NFS DS. The folder is that, and then the IP address is actually the same as the one that we used for the iSCSI target. So we'll add that. Then I'm going to do the same with the other IP address of my NFS server. I'm not using Kerberos authentication for this, so to use authenticated NFS, it needs to be done through Kerberos, and that requires that the host is joined to your Active Directory domain. So I'm not going to be doing that for this. My NFS server is configured to allow this host without authentication. Of course, you might not want to do that in a production environment, but in my case, that NFS host is very carefully controlled. So we'll see the NFS data store has been created successfully, so we can go and take a look at that there. We're going to take a look at files, and we can see my NFS NAS has created a folder called ESX hosts on there by default. You'll see there that we have, it is connected to this particular host. Now I'm going to say mount data store to additional hosts, and I'm going to tick the other host. and it will now add the same configuration to the other host. And that's it. That's NFS configured. We can take a look at the files there. We can go and create a virtual machine. Let's do that. So, new virtual machine. VM1. Just do this as an example. So we'll select a host and put it on host 2, and we'll select our NFS data store. These are all the same options that we've been through previously. Windows 10 64-bit. When we take a look at our hard disk, we can see there that the only option with an NFS data store is thin provisioning. If you want to do thick provisioning on an NFS data store, there are some other requirements. However, by default, an NFS data store will be thin provisioned VMs. In this module, we have explored some of the most common storage types we use with vSphere. Now, if you've been researching vSphere already, you might have noticed a couple of notable omissions: vSAN and RDMs. We cover vSAN in a module of its own later on, as this links into so many other vSphere features. RDMs, or raw device mappings, are not on the vSphere Foundation's blueprint, so I haven't covered them here. But in brief, RDMs allow you to map a virtual machine directly to a storage device, instead of creating a data store. There are a very small number of cases where this is required, for example, if you're using Windows failover clustering. Some people believe that RDMs provide better performance than a VMFS data store, but this isn't the case. If you need to put your VMs on RDMs for performance reasons, then there must be an issue somewhere. Thank you for watching. Now we have an understanding of vSphere networking and storage, we can move on and take a look at the features available to us in our cluster, such as HA, vMotion and DRS.